Hello, my name is Dylan Radford and I'm the Solution Owner for Geology for DSG. In this presentation, the Geology Product Owner Alice Butt will be covering the new features in the DSG 10ep.5 series, particularly as it relates to core geology interpretation. We hope you find these new features exciting and insightful to help with your workflows. And thank you for tuning in to this presentation. The information below depicts timestamps for the relevant releases of the DSG 10ep.5 series. For those wishing to skip ahead, you may do so by going to the timestamps listed below. I will now hand over to Alice for the remainder of the presentation.
Hello and welcome to this demo on the new features in 10ep.5 Decision-Based Geology. My name is Alice and I'll be presenting the new features that have been developed for geological interpretation workflows focused around well correlation and well analysis. In 10ep.5 we have added enhancements and quick analysis tools to help the geoscientists to get value from the data rapidly, which we think will be of the highest benefit in the fast-paced environments in the industry. The new features enhance various different workflows, paying some attention to ops and well site geology workflows, as well as continuing to improve the standard exploration workflows. We have worked on improving user experience by standardizing some of our existing tools and property editors. In addition, by streamlining workflows and removing unnecessary steps and reducing the time it takes to find data, we can reduce non-productive time. Alongside the new features, we have continued to stabilize DSG, in particular with improvements on GeoShaper functionality, well projections in section views, and correlation view performance with large datasets. So the new features that we've worked on are found in multiple areas within geological interpretation. We've worked on dip date and decline curve quick analysis tools. Lithology strip and log curve work focuses on setting up display options more quickly. The Stratcolumn surface pick and horizon work was on improving the display and allowing the user to customize what they see in the correlation view, a lot of which is foundational for aiding the geoscientists to understand the subsurface and identify target reservoirs. So the new feature on horizons now enables us to display 3D horizons in correlation view alongside all the other wellbore data. This works for both depth horizons and two-way time horizons. The horizons are not editable in correlation view. It's just a way to let the user or the geologist to see the interpretation made by the geophysicist to enable some collaboration and better understanding of the surface. The horizons have many different display options. You can choose which track to put the horizon line in, whether it's a wiggly or straight line, the colours, the annotation, and this all helps to understand what's going on and to correlate between the wells with this new piece of data. The dip data improvements are in multiple areas. We have a new tool in the editor toolbar called the apparent dip tool. This has moved from horizontal well correlation into the view editors so that we can use it in both the map and the section views. In the map view, it will obviously only be apparent dip because the angle of your section view may not be at the maximum dip. You can draw a line between 2 points and this will automatically calculate your dip value and the azimuth that your line is portraying. In the map view, you also have the option to choose what data you're making the calculation on. So this is between the grid, the framework surface and the horizon. If you have multiple different things displaying in map view, you can click on the option to show only the selected surface to see what surface you are calculating the dip data on. We have also improved the scale for Dipmeter data in the correlation editor, so now you actually have scale readings and you have a symbol for the data. And we've added the option to display the Dipmeter by strike in map view. So previously we just had the dip and the dip azimuth, and in many cases users were having to relay the data with a 90-degree difference, which is very time consuming and could bring in potential errors. So this way we're making it much easier for the user to see their data in the way that they need, that will provide the most information to them. The decline curve improvements are focused around displaying production data as daily values. So now we can bring in daily production data and display it, and we can also change the scale for monthly data so that it displays by day. This is much more useful for geoscientists because they're used to seeing daily production values. We've also added a quick analysis tool that will calculate the average values from a user-defined interval on the graph. So the circled icon, when you click on that and you draw an interval, drag and drop across the graph, it will give you that readout of your daily average, your weekly average, and the monthly average. So this facilitates sort of quick analysis before you might want to go into more detailed analysis in some of our other applications. On the lithology side of things, we've also done quite a lot of work. We've collated a lot of, or all of the display options into one dialog rather than them being in multiple different places, and this means that we've reduced the mouse mileage and it's much more intuitive to the user. We've also added the option for lithology annotation. So when this turns on, it will display the lithology class name within the well. This can be in a separate track or the same track as the actual lithology data, and this is very valuable for transferring knowledge between users. We also have a new import tool which converts real-time mudlog data into lithology strip data. This allows the user to bring in any data that's brought over into the mudlog tables into the lithology table so that it can be displayed in DSG. This is because real-time data will bring in mudlog values. However, the user wants to see these instantly in their well in correlation view. So this tool, it only needs 3 clicks. You open up the tool from the lithology interpreter panel, and then there are some options on there for checking the data to see whether it overlaps or whether it's outside the range of the well. You don't have to make edits, but you can, and then you bring the data into DSG. This means that you don't have to completely reinterpret the lithology within DSG in case you have a separate application onshore and offshore to work on the lithology. The log curve tracker set up improvements that includes an option for alias track defaulting. So this means that when you bring in a log curve with a specific name, if there's a track in well correlation with exactly the same name, that log curve will instantly display within that track. There's also an option to show only the log curve alias member name. So this allows you, when you have a group of log curves and you want to turn on the group, it will actually display the name of the first log curve within that group that's possible to display. So this means that you have much more information specific to what data you're actually looking at. Even though it's coming from a group, it will pick out the actual curve that you're looking at within that group. This reduces the setup time for log curves, and so that you don't have to search and add the log curves independently to user-defined track. The surface pick interpretation improvements include being able to adjust the display order of well picks in views. So this is most important for when you have more than one pick at the same depth and you want to choose which pick name to be displayed at the top. This situation would happen if you have an unconformity and you want to maybe either show the younger stage or the older stage that's occurring at that depth. There's also the option to make a copy of another interpreter's pick as one of the MB3 options on a pick in correlation view. It's called a clone surface pick, and this is useful in the workflow where you might want to pick and choose from other people's interpretations to make one master set of picks, especially when you're reviewing surface picks. The Stratcolumn overlay improvements allow the user to display the surface type of Stratcolumn across all of the tracks in a well in correlation view. This means that it's much easier to understand what data falls into what stratigraphic interval, and it makes it easier to correlate between wells as well. And last but not least, we've also done a few other improvements in different areas. One of them is the well info pop-up box. So this now has some options that you can add. So when you're hovering the cursor over a well, it can show you things such as the well inclination and the well azimuth. This is really important if you want to know the angle of your well bore in relation to all the other data that you're looking at. In Cube View, we've added the option for well perforation display as live data, so it's to the same standard as casing and liner data. There are options to color this by status, such as open or closed, and there are other display options to show it as a circle or a triangle, etc. And this is just enabling the user to set up the display in the best way to provide the information that they want to convey. So with the new features in 10ep.5, we've enhanced various different workflows to reduce non-productive time and bring in quick analysis tools. We've also started to work on adding more data types into the correlation view so that it can be used in even more workflows that bring the disciplines together. Landmark acknowledges the provision of data for use in the video, including the publicly available Norway hydron data. Thank you for listening. Hi, my name is Alice and I'm the product owner for Decision Space Geology Interpretation functionality. And today I'll be showing you some of the exciting new features added as part of DSG 10ep.5.4 for well interpretation and analysis workflows. The new features include quick analysis tools, which improve the interpreter's understanding of the data and its impact on the subsurface model. We also have more data types that can be displayed on a well, which integrate interpretation from other disciplines. And we have also added various improvements to display and interpretation options. These improvements standardize tools and property editors, streamline workflows, and provide additional geological rules to assist the interpretation. Alongside new features, we continue to maintain current workflows through the stabilization of the software. So now I will go into a bit more detail on each of these new features. We can now display image logs in DSG. These are also known as multi-dimensional log curves, and they allow the raw data that is collected from the 360 degrees around the well bore to be displayed in a well track. Image logs are used to interpret subseismic structure and sedimentology, and by displaying an image log in the well, it helps to check the interpretation of the strata and facilitate cross-discipline communication with petrophysicists. There are multiple display options, including standard image log color maps, color range selection, opacity, and resampling to smooth the image. In addition, the loading of image log data requires a DLIST format file. However, if the log curves are brought in individually, there's an option to quickly combine the log curves into one array when managing the image log data. We have added the ability to display a new data type, dip zones, in a well, as well as adding the option to display by class, which gives color and symbol shape depending on the type of dip, i.e. maybe it's a fault dip or structural tilt dip. These improvements have made working with structural geology interpretations much easier, as it requires less data management and display style setup time, and the use of dip data will allow cross-discipline integration with structural geologists. Dip zones are used to identify intervals where the dip data has similar values, potentially identifying a new strata or rock formation, and so this is a very valuable new data type. We have also added more filters for dip data, such as the class and subcrop and supercrop filter. On the right, you can see the option to filter out dip data that subcrop or supercrop a well pick or horizon. This allows you to view the closest dip value to the selected surface. The map image view shows sediment transport direction for dip data in various formations, and so the use of this filter would help to focus in on just one formation and highlight any trends. We have also added the apparent dip tool to take quick readings of the dip and azimuth in section and map view. This option is found on the map and section view toolbar. We can now display horizons in correlation view, and this displays the intersection of a horizon with a well path in a well track, so that it is much easier to compare the horizon interpretation with the rest of the well data when working on well correlation. The horizons can be turned on in the inventory, like all data types, and they are not editable in correlation view. If these horizon intersections need to be converted to well picks, for instance to create acoustic picks, there is a quick launch option for Wellbore Analyzer tool where this functionality is possible, and it pre-selects the horizon information to speed up this workflow. Another new data type that we can now display in DSG is biostratigraphic data from StrataBugs. StrataBugs is a widely used industry application that enables the interpretation of biostratigraphic data, and by bringing in this data into DSG, we ensure standardization and cross-discipline collaboration. I should mention that this data cannot be edited to protect the biostratigrapher's interpretation. The biostratigraphic data brings the important geological age constraints to the interpretation. This data includes sample depth information, biozones, and chronostratigraphy that you can see in the image on the right. And this data can be visualized on a well in correlation view, section, and map view. Biozones are an interpretation of a group of fossil species events that indicate a sediment age and environment of deposition. It is very valuable for validating well pick interpretations and properly understanding the sequence of events that result in the formation of strata in the sedimentary basin. So now I will show an example of how these new data types can really improve interpretation of the stratigraphy. In this project on the Volve oil field, I am interpreting well tops on well 11B, and I am using well 15A to help the interpretation. I am trying to interpret the heather formation, and in this case it is difficult to make an interpretation, as there isn't the obvious peak in gamma ray in well 11B. And the lithology also isn't very definitive. So we can bring in a constraint from the horizon interpretation. And with the horizon intersection I can make a tentative interpretation, but to give me more support in this interpretation I can bring in the image log and dip data. The dip class display style is particularly useful to ensure that the correct dip readings are being used, and this option is found on the display properties. The dip zones in the far right track are the most useful for visualizing the structure, and these structural zones agree with the horizon, showing a dramatic change in dip direction above and below the horizon, making this interpretation much more confident. So now I'm going to work on the Huygens formation, and as there's not a horizon interpretation for this formation, I've brought in the biostratigraphic data for these wells. In 15A, the Huygens formation sits between biozone JZ44 and JZ28. Therefore, we can pick the Huygens formation here in the 11B well, where the biozone is JZ27 to JZ30. So now I move on to the age gap analysis tool, and this tool allows the biostratigraphic data that we just saw to be used to its full potential. The tool creates maps of the geological ages that are taken from the biozones in the well, and multiple maps can be created at once to allow rapid iterations of the workflow. These maps make any anomalies in the well pick or horizon interpretation very apparent, and this mismatch in geological ages identifies where interpretations need to be amended. The isochron maps make it much easier to identify the extent and age of age gaps in the data, and these could be due to unconformities. Furthermore, the understanding of the age of the strata and when the sediments were deposited facilitates the interpretation of connectivity of strata. So let's take a look at this in action. The age gap analysis is a geology tool, and when opened, the biozone scheme, well list, and the surface of interest needs to be selected. I'm analysing the Huygens formation top, and here the age data is calculated from the closest biozone to the surface pick and presented in a table for initial validation. We can then quickly create a map of the subcrop age, and this map shows mainly consistent ages of 160 to 164 million years. However, there seems to be an anomaly in the south around well 15, where there's a much younger age. So we can check well 15 in the correlation panel, and here I have highlighted the zones where the Huygens formation should be placed in pink. And even though the top Huygens is picked at the sudden decrease in gamma ray, the biostrat actually indicates that this interpretation should be deeper. So this new pick position actually ties much better with the lower gamma ray values that we see in other wells. So now that I've edited the interpretation, I can refresh the age gap analysis and rerun the map to see how the edit improves the map and removes the anomaly, and thus demonstrating how the age gap analysis is a great tool for quality checking interpretations. We can also make an isochron or age gap map, and this helps to identify where there might be missing stratigraphy. I'm also creating a supercrop map to compare with the subcrop map. And this will help me understand whether age gaps are before or after the Huygens formation boundary. So the age gap map here shows mostly 0 million years, or no age gap in purple, but seems to show missing time of up to 16 million years in the northwest. When we look at the supercrop map, we can see that this is probably where the age difference is coming from, rather than the subcrop map, and therefore this indicates possible onlap, rather than an erosional unconformity. And this is valuable for determining that it is less likely that the hydrocarbon producing interval in the Huygens formation has been eroded. So, the new auto display option for Stratcolumns requires only the minimum number of picks to be interpreted for the Stratcolumn to display the full extent, thus reducing the potential error and the time it takes to make sure that the Stratcolumn displays correctly when creating or editing an interpretation. So, for example, when interpreting lithostratigraphy using well tops, only formations need to be interpreted, and the logic will know how to display the groups or supergroups. This new logic has inbuilt geological rules that will display the Stratcolumn correctly in reverse stratigraphy and in faulting scenarios. There is also the ability to overlay the stratigraphic unit on all the tracks in a well to easily visualize whether all the data conforms to the stratigraphic divisions that have been interpreted. More surface pick interpretation options have also been added to support the simplified well picking strategy. So this includes the option to edit multiple picks together when they're at the same depth, options to copy picks and reassign a new name, and the ability to change the name of a surface. So this will cause all the picks to change their name. So these new tools or options allow more user control over the data and gives the user flexibility to change the interpretation over time. For example, the early interpretation is usually at a larger scale, and as new data is collected, the interpretation can become more detailed and may need to be changed significantly. To further enhance the interpretation workflow through stratigraphic techniques, we have also vastly improved the algorithm for displaying wells in true stratigraphic thickness when using structural frameworks in the session. This algorithm takes the surface types such as unconformable or conformable and the faults into account to provide the most accurate stratigraphic thickness. And if an unconformity makes this calculation less robust, a warning message indicates where in the well that this occurs. The ability to segment a well by turning point in stratigraphy has also been added, which you can see on the right. This is extremely useful when the well passes through stratigraphy in reverse and the beds are dipping. So I'll delve into this in a little more detail in the next demo. So here we have the well that I was interpreting previously, well 11B. There's also a stratigraphic column for the oil field that has been previously set up. And so rather than having to interpret all of these units to display them in the well, I can just turn on the auto pick generation option in the Stratcolumn display properties. And with only these 3 picks, all the appropriate units will display. So I'm going to continue interpreting tops. However, as you saw previously, this well doesn't show really distinct markers, and there are some repeating patterns which can be difficult to interpret. The reason for this is because the well is passing up and down through the same stratigraphic unit, and this can be seen in section view. This makes it very difficult to interpret because the well data may be stretched and also in reverse. So, to make it much easier to interpret, the well can be segmented by turning point in stratigraphy, and we can change the domain to true stratigraphic thickness so that the sections in reverse display alongside other segments and in the correct orientation. The new algorithm for TST calculates TST at each directional survey points as seen on these wells in the small dots. So with this new segmenting setup, it is much easier to interpret and identify the same pattern in adjacent segments, as I am directly comparing data in the well from the same stratigraphic interval. So as I create picks and save them, the auto pick generation Stratcolumn option is creating the units correctly, and I could save these units to OpenWorks to create the picks for other workflows. So I'll go through a couple of the other improvements that have been made. In the log curve functionality, we've made some improvements to reduce the time to set up log curves in a well layout. This includes alias track defaulting, where the track has the same name as the log curve, then the log curve will automatically display in the track. The other option, to show only the log curve alias member name, ensures that when a log curve is part of an alias group, the track header will show the individual log curve name rather than the alias name when the group is turned on in the inventory. Lithology interpretation has also been improved by collating all the display properties into one window to reduce mouse mileage and to make these options more intuitive. There is also a new option to display lithology annotations in a track in the well. We are also catering for operations geology workflows by allowing the quick transfer of real-time mudlog data into the DSG lithology data type. So this means that lithology interpretations captured on the rig site can be easily incorporated into the main project so that quality checks can happen as rapidly as possible whilst drilling. To further facilitate workflows that need close attention to well data and the display of engineering data, we have added the option to display wellbore inclination and azimuth on the cursor readout. So this can be seen in correlation and section view. We have also added the ability to display perforations in 3D that are coloured by status, such as open and closed. So DSG has various well analysis tools, and here I am showing the functionality for displaying a decline curve for the production data in a well. This is found on the single well info panel in the section under production data. We have added the ability to display the daily production data in a decline curve, which is a new option in the display properties. We have also added a quick analysis tool for displaying the averages. You can select an interval on the graph and the readout will give daily, weekly and monthly averages for that interval. And this gives a way of rapidly analysing the data. So, as you've seen, we've added many new data types, display options and quick analysis tools to enhance your well data interpretation workflows. More detailed information can be found in the help pages of Decision-Based Geosciences, and for additional questions, please contact your local landmark support. I'd like to thank Equinor and the former Volve license partners for the use of the data that has been shown in some of these examples. Thank you very much for listening. Hi, I'm Alice, and here I'm going to present the new features for the Decision-Based Geosciences well interpretation workflows in the 10ep.5.4 release. These new features build on the functionality that we have added throughout the 10ep5 series and include resampling options on the image log data type, the ability to directly connect with the StrataBugs server for live biostratigraphic updates, and the ability to display the location of the turning points in stratigraphy in an undulating horizontal well. These features continue to help to create a more accurate stratigraphically and structurally plausible subsurface model through enhancing the well interpretation workflow. So to further improve the image log data display, the image log display properties have new resampling options. These options change the resolution by increasing or decreasing the number of columns of data that make up the image log display in a track. See the picture on the right showing the effect of adding or reducing columns to the image log display. When auto resample is selected, the image log resolution will start to decrease when the view scale passes a specific value, because as you zoom out, the image log doesn't need to be used for detailed analysis, and so the resolution doesn't need to be as high, and this helps to improve the performance in the display and allow the display to refresh much more quickly when working with large image logs. There are also manual options to increase or decrease the column count so that this functionality is fully customizable. To facilitate working with horizontal wells, we have added a new option to show the turning points in stratigraphy in map, section and correlation view. So this works in combination with the new TST calculation, which was implemented in the last version of the 10ep5 series, and that calculation uses a structural framework to determine whether a well is moving up or down in stratigraphy. When the show turning point in stratigraphy is turned on, a symbol is placed on the well path to mark the location where the well goes from moving down in stratigraphy to moving up in stratigraphy. In the example on the right, we are using green stars to show these turning points. So these turning points are extremely valuable when interrogating the well in section map view, so that we can compare and understand the position of the well path and the data on the well in relation to the stratigraphy when interpreting well tops. So now I'll move on to the enhancements for the StrataBugs Biostratigraphic data display in DSG. This biostratigraphic data is a new data type in the 10ep.5 series and is very valuable as it provides an age constraint and an environment of deposition information to the interpretations. With the release of the StrataBugs version 3.0, we are now able to set up a direct connection and receive biostratigraphic data from the StrataBugs database whilst in DSG without having to export an XML file from StrataBugs. The functionality requires a license to the StrataBugs application, as well as a connection with the decision space integration server to be set up as an additional data source in the DSG Add Data window. The virtual database, which converts the StrataBugs data into a format that DSG can read, can be found in the help documents, along with detailed steps on how to set the connection up. Once connected, any updates in the StrataBugs database can be viewed in DSG immediately, and this ensures that the data is constantly up to date, allowing for more accurate interpretations. So all these features continue to enhance the well interpretation workflow through reducing non-productive time and making it more easy to visualize and understand the stratigraphy and structure of the well data. So I would like to acknowledge Equinor and the former Volve license partners for providing the data that we've used in the images, and I'd like to thank you for listening. Hi, my name is Alice and I'm going to present the new features that are available in the DSG 10ep.5.4 release for geological interpretation workflows. In this release, we have focused on incorporating uncertainty into the geological interpretation and structural modeling workflow, so that it is easier to visualize the uncertainties and use that understanding to impact the subsurface interpretation in an iterative workflow that refines and improves the model. The uncertainties are also very valuable in volumetrics, well planning, and risk management. We have added the option to display the wellbore cone of uncertainty to cube view and HWC section view, and integrated uncertainty into the new reservoir scale frameworks. This is a new type of framework in 10ep.5.4, and more information can be found on the 2D mapping and frameworks What's New video. To complete the workflow using uncertainty, we now enable framework surfaces to be used in Wellbore Analyzer to find prognosed pics for well planning reports, and we can convert framework contours to polygons to use in volumetric calculations. A cone of uncertainty can be displayed along the well paths in the cube view, wellbore view, and horizontal well correlation view. The cone is drawn using the covariance values stored in the preferred directional survey for the well. These covariance values can be calculated in well planning or Compass and transferred to the OpenWorks wells database. This allows us to visualize the uncertainty of the position of the well and how it could impact the interpretation of structure and well planning. The option for the cone of uncertainty display is available when I right-click and select the well uncertainty option, and this will turn on the cone for all wells with covariance data. There is the option to change the color and opacity of the cone as well. As well as wellbore path uncertainty, we have also built in functionality to be able to display and use structural framework uncertainty. We incorporate the wellbore path uncertainty with horizon, velocity, and pick uncertainty to create an uncertainty envelope in depth. This functionality is available in the frameworks as an additional option that allows the user to input uncertainty values and to calculate the uncertainty for each of the framework surfaces. When the framework is saved, then the input values are saved to the framework. The output are two additional frameworks, a P5 and P95, which capture the depth range of the surfaces according to the uncertainties, so that the uncertainty of the structural model can be visualized and used in volumetrics and well planning. Consistency tests are also available to determine whether the uncertainty inputs and outputs are reasonable. So now I'll go into a quick demo. Once a reservoir scale framework has been created, we can go into the uncertainty workflow. So when you're in the framework workspace, there is a new mode for generate uncertainty surfaces, and this turns on new columns that allow you to input time and velocity uncertainty values. We also have columns for pick uncertainty. There is a directional survey uncertainty that is calculated from the covariance values in the database. And then there is an interpretation uncertainty for each pick, where you can manually add an uncertainty for the depth of the pick. This value defaults to 0 meters if no value is entered. So all these uncertainties are combined and used to calculate a P5 and P95 surface for each framework surface. As well as the uncertainty inputs, there are also additional columns for consistency tests that check that the uncertainty inputs are reasonable. The tests highlight in red if the results are outside expected ranges. These ranges can be changed to custom values, and when the framework is run, they don't impact what data is used in the surface builds. The red highlight is just to help with checking the uncertainty data and the results. So here we have the results. There are three framework outputs, a P5, a P50 and a P95. The P50 is the original framework, and here I've matched the colors and reduced the opacity for the P5 and P95 to make it easier to visualize the uncertainty envelope, or range of depths, at which the surfaces might be in the subsurface. So I'm going to go to the section view, as it is easier to visualize the effect of uncertainty, especially at the picks. When the P5 and P95 surfaces are turned on here, they show as dashed lines, and you can see that they pinch at the pick location due to the reduced uncertainty from the pick data that is more detailed than the seismic interpretations. So we can go back to the framework workspace to check on our results, and we can do this through the consistency tests that were calculated with the run. The seismic and pick uncertainty difference and the overlap tests are within the expected range, indicating that the values that we input for those uncertainties are reasonable. The mistype bias test, however, is showing that there might be a problem with all this red highlighting. So to understand the results, we need to look at the picks for an individual well. So we select all the picks and then filter by one of the wells and sort by increasing MD. And the results show that the upper part of the well, there are negative and positive misties that may cancel out. However, the mistie increases dramatically with depth. So going back to the section view, you can see that this is because it becomes a horizontal well at these depths, and so this increase in mistie is expected. Once framework surfaces have been built, they can now be used in the wellbore analyzer to find intersections with well paths. The wellbore analyzer can now be launched from inside frameworks to facilitate this workflow. When the uncertainty surfaces are used to find the intersections with a planned well, the picks that are created can be used as predicted picks that can be provided to the drilling engineer. In addition, capturing the location of the intersections in wells as picks is useful as a record of the model that can then be compared with the updated model after new data is collected and interpreted. The wellbore analyzer can now be launched from inside the framework under Settings, Post-Processing and Generate Prognosed Picks. And then we go through the normal wellbore analyzer workflow where we select wells, and then there's a new tab for frameworks, and here the active frameworks are already pre-selected. When we click on OK, the calculations will run and picks are created at the intersections of the framework surfaces with the wells. Then we get a report that details all this information. We can take a look at the results in the section view. Here are the picks that we created, and the name of the picks have a suffix according to the framework type, and you can see how they tie with the P5, P50 and P95 framework surfaces. These picks are saved with additional information, so in the Well Data Manager we can see that the kind column is filled with the word prognosis, so the newly created picks are easy to find and to filter. We have also automatically saved the new picks with other additional information. For example, the framework surface number is saved into the geologic feature column, so you can determine which surface the pick was created from. The qualifier column also saves the acronym for the framework type, such as reservoir scale framework, traditional framework, or complex geology framework. So when we have built the uncertainty frameworks, we can now easily save framework surface contours to polygons. The ability to save individual contour polylines to a polygon ensures that the framework build is connected with multiple other mapping workflows that require an AOI defined by a contour. This new functionality allows one or multiple contour polylines to be saved to a polygon using the MB3 action. If the polyline is an open contour, where the ends of the contour don't connect, then it can't be converted to a polygon unless it is edited and closed. In this example, we have a closure that is a different size on the P95 compared to the P5 and P50 surfaces, and we want to use this closure that you can see in the contours to model first pass gross rock volumes. So first we need to save out the framework surface contours to a contour set through right-click on the framework surface of interest. With the contour set, we need to make sure that we are in edit mode, and you can see that there's a table of all the contour values where multiple contour polylines can be selected at once. However, we are interested in just one contour, so we MB3 on the contour polyline and save as polygon. There is a prompt to enter a name and save out the contour as a polygon. If the name matches an already existing name, a warning message will appear and prevent you from creating the polygon. Here you can see the polygon that I made for the P50 as well as the one that I made earlier for the P95 closure. So now we can use the polygons in different workflows, and I'm going to show how it can be used in volumetrics. So in the framework, go to the Volume of Interest tab, select the VOI definition to the polygon option and select the polygon from the database. Then toggle on compartments and refresh the framework. And we can do this for the P50 and P95 polygons to compare the results. Here I'm selecting the interval of interest, and you can see the results on the Volumetrics tab. The Save as Polygon is not just for single contours, it is also possible to go to the table in the Contour Interpretation panel and select multiple polylines at once, then go back to the map view, select MB3 and save as polygons, though only the closed contours will save to polygon. So that covers all the new features in the DSG 10ep.5.4 release, and you can see how we have focused on incorporating uncertainty into the interpretation, as well as being able to use this uncertainty in analysis and reporting workflows. I would like to acknowledge Equinor and the former Volve license partners for the Volve dataset that was used in this demo, and thank you for watching, and I hope the new features will help to improve your workflows and an understanding of the uncertainties in the subsurface.